Chapter 3, Number 77, a classic. A passenger on a stopped bus notices that rain is falling vertically just outside the window. When the bus moves with constant velocity, the passenger observes that the falling raindrops are now making an angle of 15 degrees with respect to the vertical. What is the ratio of the speed of the raindrops to the speed of the bus? And what is the speed of the raindrops given the bus is moving with a speed of 18 meters per second? Both of those, I guess, relative to the ground. So now we're saying that relative to the ground, the water drops straight down. We'll call that V water ground. But once the bus starts moving, we have that the water, let's pick a different color, is moving this way, something like that, and that's the velocity of the water relative to the bus. And then out there somewhere, the bus is also moving relative to the ground, so we'll say bus relative to ground. And then, now we can apply the relative motion formula, which tells us that the velocity of the water relative to the ground is equal to the velocity of the water relative to the bus, plus the velocity of the bus relative to the ground. So we can take our vectors and start saying, well, the downward guy has to be the same as this one plus that one. And then they say we make an angle to the vertical of 15 degrees, so that's that angle is 15 degrees. And we can write in all our guys. We can say this is VBG, and this is WG, and this is VWB. Then if we go back to the problem, we can say, what is the ratio of the speed of the raindrops relative to the speed of the bus? So we're really saying we want velocity of the raindrop relative to the velocity of the bus. Both of those with respect to the ground implicitly. And we can see that that is from our triangle, that is the opposite side, that is the adjacent side. Oops. Over the opposite side. That VWG is adjacent to the angle they gave us. So that's the same as 1 over the opposite over the adjacent, or 1 over the tangent. So what we want is 1 over tangent of 15. And that apparently comes out to be 3.73. So the raindrops are going at something like 3 times the speed of the bus. And then we can just say, we can just use that and say, well, if that ratio really, let's give ourselves some room here, then VWG is 3.73 times the speed of the bus, which was 18 meters per second. And so the velocity of the rain is 67.2 meters per second.